Okay, so I got the quiz already. Go 1-5, 1-6, and finish up 1-6, do 1-7 on Thursday. My goal is to give you the review sheet. That way you have the weekend to get it started, get a look at it. May not be able to do everything because 1.7 may not be completely done, but you probably can do 2/3, 3/4 of it. Next Tuesday, finish up all chapter 1. Next Thursday, review. Following Tuesday, October 8th, would be the turn in your homework, chapter 1 test. Okay. Over here, 1.4, little homework edit. So 1.2, I already omitted 63 to 73 at the end of 1.2. But on 1.4, I'm not going to ask you this on the test, so I'm going to omit it from the homework. The last 5 questions, 67, 71, 73, 75, 77. And then on 1.7, you can omit number 61 and 63. This last week. This is your review sheet. Now, in the process of working it up a little bit more, changing it a little bit. The grafting is going to be multiple choice. Parent functions. Number 7 is a parabola. It's an x squared function. X squareds always look like parabolas. Number 8 is a square root. Square root looks just like the square root, the radical sign. It's a nice coincidence. Number 10 is an absolute value, which is a V shape. And then number 9 is the piecewise that we did in 1.4. Yeah. So mandatory on your test, you would not have to graph any of those. Mandatory by hand. Multiple choice. Bonus questions. You're going to have to graph piecewise, definitely. That would be a bonus question. But what we're going to do today, you're going to see here. Number 11 and 12. So you have examples on your review sheet, just like your test. Review sheet is not homework. You can do it or not do it. That's up to you. And your test is right. So, that's up to you. This is a picture of the function. You're supposed to graph g of x, which is based upon the picture of f of x. You're supposed to graph g of x based upon the function of this f of x. So the third page, those are the answers. I always get the question, how do you do the third page? Those are the answers to the review sheet. I would not ask you, I wouldn't give you a review sheet unless you had the answers to the review sheet, because that way you know whether or not you got them right or wrong, so you know what questions to ask. So that means, but you have to be able to understand what we're doing here in 5.1 today. It's all about how graphs change. What makes a graph flip upside down, right side up, shift left, shift right, shift up, shift down, maybe even flip across the x-axis. Now, I'm not going to ask you to flip one on your test across the x, but they can. And I'll show you how and why. Our parent function. F of x equals x. 1 times x to the first. That's a linear function. One times x to the first. X to the first makes it linear. It's a line. And we know how to graph anything that would change it. Anything that might change it would look like y equals mx plus b is what we always want to try to find. So we know where to basically place the line, and then the slope tells us how to get to another point. The next one. I'm just going to go ahead and go in there for absolute value. F of x is equal to the absolute value of x. Again, parent function. Absolute value is a V shape. Absolute value has a really important point you always need to start with. You always need to find this point right here. It's called the vertex. It's where the graph changes from decreasing to increasing. If it's flipped upside down, it would be where it changes from increasing to decreasing. But that point where it changes, that's called the vertex. Absolute value. Leave a little room because we're going to put some more stuff in there. And then C, the square root function. The parent function, f of x equals square root x. You cannot take the square root of negative numbers. So when you graph a square root, there is nothing to the left of 0 because you can't use these x's inside this square root. It would start at 0, 0, and it goes up only to the right. Because there's no way to get an answer that would be a negative. There's no way you're going to get a negative answer unless you have a negative out in front. So this is the parent function. The square root of 0 is 0. The square root of 1, if you plug in x is 1, we get 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. This has got It's not a vertex because a vertex means you change from increasing, decreasing, or decreasing to increasing. So not a real special name for it, but we always want to find it anyway. Just hope the first point you want to find is the first point you should always look for. You find that first point in the equation, that's what you want to start your graph from. Always looking for that. And I haven't moved the camera yet. I just got to watch that. Watch the TV. The quadratic there's function f of x is 1 times x to the second power. So a power of 2, x squared. Is this shape. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared gives you 1. 2 squared gives you 3. So this is the parabolic shape. It's got a special name, the parabola. But as a function, it's known as a quadratic function. Any x squared, anytime you have a power of 2 as your function, the biggest power is a 2. It's called a quadratic function. But the name of this curve, this is a parabolic curve or a parabola. Got a special name. It does change from decreasing to increasing. So this right here is got the name vertex. We always like to find out where we should start the graph from. This is the vertex. Just like the absolute value has a vertex. Okay. Not a vertex with a square root, but a first point. We always want the first point we should use to make a line. Okay. The y-intercept. We always want to know what b is. That's what we want to find first. So we got the line. M is always a slope. M is a slope. Given that it's a linear function. So here's what we're going to add to it. These are the parent graphs. Now we're going to maybe flip it from right side up because all these are in their natural habitats. They're all doing this basically up because it's a positive absolute value of x, 1 times absolute value of x, 1 times square root, positive 1 times square root of x, positive 1 times x squared. We can flip it upside down. Okay. We can flip it upside down if we put a negative in front of the function. We can shift the graph left and right. All we have to do is change the x value or adjust the x value. Maybe add something to the x before you square it. So instead of x squared, maybe it's x plus 1 squared. So if I pick 2 before I square it, 2 plus 1 would be 3. I'd actually be squaring 3, but I'm going to plot x equals 2. It's going to behave like a 3, but it's going to get shifted because I'm going to add something to the x before I square it. So that would shift it left and right. Or maybe after I square my, whatever I plug in, then I add or subtract something from that. So it's going to change the y value. It's going to change the height. Vertical shift. And here's what I'm talking about. You've done this. If I just gave you y equals x, y equals x. So right here, the slope equals 1 times x, and the y-intercept. Oh, by the way, what is the y-intercept on here? Good, 0. Oh, all right, I'm showing you right here. I put it over there. You see how what would have to be added in the sense that nothing is there? If I don't see anything there, then what number is there? If it was a 1, then I'd see a plus 1. I don't see a plus 1. At least not since I stopped reading. That's how 1's all over the place. Okay. That was back when I was 5. Zeros and ones. Ones and zeros. Oh, okay, look. I gotta give you some. But it's a 1 times x to the first, so it's linear. There's nothing there. People make stuff up all the time. They really do. They really do. So x plus 0. So it goes through the origin with a slope of, what's the rise over run if I wrote it as a fraction? 1 over 1. So you go up 1 over 1, there it is. There's 1. So what if it was y equals x plus 3? So what's the slope here? 1 over 1. 1 over 1 still. What's the y-intercept? 3. So now you know the graph is going to start and cross the y-axis at 3 instead of 0. Where do we start the graph? We start it here. And then we go up 1 over 1. So this will be 1, 4. And there's the graph. We took the old y equals x and we added 3. We added 3 to all of those old answers. This used to be a 0. Now it's up there at 3. This used to be a 1. Now it's up here at a 4. Everything got shoved up 3 units. We took the old y coordinates, we added 3 to them, shoved it up 3 units. You mess with the y value after you perform the function. If we add something to it or subtract something to it, it's going to move the graph up or down. That's a vertical shift. Okay. If I add something or subtract something from the absolute value, it's going to move the graph up or down. If I change x before I take the absolute value, then it's going to move the graph left or right. If you mess with x, you're going to move it left to right. If you mess with the y values after you take the absolute value, it's going to move it up or down. So this is where we're at. This is what the all. Y is equal to, there's some a times f of x minus h. And then after that, you have a plus k. Your job is going to be to identify a, h, and k to make a graph. Just like when you write a linear equation or when you have a linear equation, 5x minus 2y equals 18. And you want to graph it, so you got to solve for y. You need the slope and the y-intercept. Subtract 5x. Negative 2y is equal to negative 5x plus 18. Everybody gets divided by negative 2. So y is equal to 5 over 2x minus 9. Once you have it in slope-intercept form, now you can identify what's the slope. 5 over 2, and what's the y-intercept? Once you have it in slope-intercept form, you're picking out the slope and the y-intercept. Your job is to figure out, when you see this, for any given graph that you'll ever have to do in your entire life from now on. Identify what's AH2K. I told the co-rec today that tomorrow in the trig class, we're going to be starting with y equals a sine b x minus h plus k. The trig functions have an h and a k as well. Their a is a little bit different because they're the sine curves and cosine curves, and all the trig curves, they're periodic. So B controls how long it takes to complete one oscillation that affects the period. A controls the amplitude of the graph. Because it goes up, it comes down, it goes up, it comes down. But everything that we're learning right here applies to that. So if you understand what A, H, and K do right here, it will apply to that. It'll apply to any kind of graphing you'll ever do, no matter what. So if you take the time to get it down now, your life will be so much easier forever. Don't fight it. Don't guess, don't fight it. Okay. The bottom line, the A is going to control whether it goes right side up or upside down. All of these are your basic, again, the parent function. They're right side up. If I put negatives in front, if I put a negative in front of that absolute value, then all of these positive y values would now be down below. Did you have a quiz return? But I don't have your quiz. Agree. Yeah. You have your quiz? Yeah. Well, if I don't get it in the next minute, I won't take it. I don't know if you read the directions or not. I mean, I shouldn't have to happen. Because if you would have come up and put me in the class, well, can I come this in? No. Oh. Go to the developer, writing the stuff up and so A controls ups and downs. So basically, if A is less than 0, what kind of numbers are less than 0? Negative. It's negative. It's going to reflect. And when we say reflect, we mean, well, it's going to flip. They're going to flip it across the x-axis. If there was a negative in front of that square root of x, then this up here would now be down there. If there was a negative in front of that x squared, then this would flip down like that. If there's a negative in front of that absolute value, then this would be down here like that. Everything's going to flip. Positives become negatives, negatives become positives. Okay. So when you're looking at the graph, you got to make, what is A? Is it positive or negative? That's all you got to think about. Positive or negative? H is the horizontal shift because H is locked inside parentheses with X. If H is not in, if you don't have a parentheses with your X, if there's not something added or subtracted in a parentheses or inside the function with your X, you ain't got no H. That's really horrible English. You do not have an H, or H is a 0. You don't have a horizontal shift. In order to have a horizontal shift, it has to be inside the parentheses or inside a function with X, because it's changing your X value. So if you just have g of X equals X squared plus 2. Now, when you see this, you go, okay, that's X, and the next thing I see is H. So the next thing I see is a 2. That's not H. Because if it's an H, it would have to be in the parentheses before the square happens. H lives with X. H changes the X value. So if it's not in parentheses, it's not the H. If it's after the square, that's the K value. And we'll get to that in a second. So H is the horizontal shift. All right, you got to live this next part. You got to live it. Don't mess this up. Don't muck this up. It's X minus H. It's X minus H, which means the negative is already there. When you take out the H value, because you have to be able to look at that and say, all right, I want to identify, you said we need to know what A, H, and K are. So A out in front. I need to know what H is. Yes, absolutely. So I'm not going to bother making jokes. You don't get any of my jokes in the first place. I need to identify what the H is. You're going to have to take out the opposite sign of what you see. H is the horizontal shift. That negative has always been there to begin with. It's always in the form of X minus H. So if you see X minus 2, H is positive 2. If we saw square root of X minus 2, then this H is a positive 2 because it's already square root of X minus, there's already minus, and then H. So H would have to be a positive 2, and then this graph would shift 2 to the right. Everything's going to shift 2 to the right. Because you're messing with the X value, you're going to mess where that first point's going to get plotted first. Think about it. Square root of X plus 2, or minus 2. We can't take the square root of what kind of numbers? Negatives. So if you think it's going to go to the left, if you think it's going to go over here, then you're saying, I can take the square root, plug in negative 2, and then take away 2. Well, that's taking the square root of negative 4, and that's not allowed. It's not going to the left. You see the X minus 2, the smallest number you can plug in is positive 2. The graph has to start here. Everybody is moving 2 to the right because H is positive 2. So you're going to take up the opposite side. I see minus 2, H minus 2, sorry, X minus 2, H is positive. If this was parentheses X plus 2 squared, so right here it's in the form of X minus H squared. You're looking at plus So H has to be -2. The negative is built in. So when you identify H, take out the opposite sign for H. It's going to go in the opposite direction of what you're looking at. I see plus, we're going left. It's a -2. So this is going to go this way, -2, and it's going to shift over here. All of the values are going to go 2 to the left. So this will go here, this one's here, that one's shifted there. This point right here is going there, that one's going over here. It's just a little jump to the left. Okay. For the rocky people. It's a built-in negative. H is the opposite side. K's got a plus in front of it. K's got a plus in front of it, so keep the sign. K for keep. I see +5, K is +5. See -7, K is a -7. K is the vertical shift. It's going to move the graph up or down. Okay, it's going to slide it vertical. So because of the plus in front of it, you're going to keep the sign. H is the opposite sign. K, you're going to keep the sign. You put the ordered pair. H is with X. H is with X. H is sliding it horizontally. The ordered pair, H, K, is the first thing you want to plot. Identify H and K. That is exactly where you're going to draw your graph.
Just to clarify, H slide X.
And K is like Y. A changes to Y value. Because once you've taken the function, so if I have we bring that absolute value down here. We're going to do example number 7, which is 7 and 9. No, we're doing number 9. 9 for 2. If we do this absolute value of X, and then go plus 1. So let me write this out here. Here's what f of X is equal to an A, absolute value inside of X minus H, and then we have a plus K. If A is a positive, if A is greater than 0, if it's positive, then the V shape is going up. And if A is less than 0, if it's negative, then you're going to draw it upside down. HK is the vertex. The ordered pair is the vertex of the absolute value. For the square root, it's going to look like this. F of X is equal to, might be a number in front of your square root of inside an X minus H, and then after the square root, you might have a plus K. If A is positive, if it's greater than 0, it's going to go up to the right. And if it's negative, it's less than 0, you're going to flip it, and it's going to go down to the right. And then the ordered pair, HK, is going to be that first point. The first point you want to label. And for the quadratic, f of x would have some a times x minus h squared, and then you have a plus k possibly. And again, if a is positive, if it's greater than 0, it's going to open up. Like a normal graph. If it's negative, you're going to flip it upside down. If it's less than 0. And that ordered pair, the HK, is the vertex. So if I saw this, I would probably hope you would write. I would definitely hope you would write. All right. This is a lot like a police line. I'm trying to see and identify everybody in the basic equation. And a general equation, vertex equation form of an absolute value. So I'm just trying to break this down into the pieces. A, absolute value, x minus h, and then plus k. So what's the A in front of you? Positive what? Positive what? It can't be 0 because 0 times absolute value would just be 0. We would have it 1 times. So since it's positive 1, we know it's going to be in that direction. Let me go up. V shape going inside. What's inside there with the x? H equals what? Now what can H equal? H is 0. X minus what? We got the 0. Absolute value, H would have to be a 0 to just get x. And then plus 1, so that plus 1, that's the k. So the vertex is at 0, 1. And then it's going to go in that direction. It didn't flip, so don't flip it. It didn't move left or right, so don't move it left or right. The only thing that happened was every one of these old answers got moved up 1 unit. Everybody got shoved up 1. And we just shifted it, lifted it up 1. Okay. You don't need to plot a whole bunch of points. You just need to identify the H and K. And then you draw your new graph based on that position. Okay. So let's take a look at number 9. So we're doing 9 and 15. The directions say, sketch the graphs of the 3 functions by hand on the same rectangular coordinate system. I don't recommend that. I mean, they want you to because they kind of want you to see how it all looks. One becomes the next one becomes the next one, but then you got to get, because it's a mess. You have too many things on one picture on one XY axis. I would much rather have it happen side by side. So. You have all that wrapping paper that I posted and I handed it out to you. Number 9. The f of x is negative x squared. G of x is negative x squared and plus 1. And h of x is equal to negative x plus 3 squared. So I made this, and I have all that time. So up here, I'm going to put just what the parent function is. Here's the parent function, y equals x. So y equals x. So there's my 0, 0, there's the vertex. I got my negative 1, 1. I got my positive 1, 1. I got 2, 4. Negative 2, 4, sorry. Positive 2, 4. And I got my negative 3, 9. And positive 3. Here we're going to graph. Saying this is what I thought you did. A parentheses x minus h squared plus k. So now for f of x, what is a equal? Negative 1. And because it's a negative 1, we know it's going to flip upside down. So right underneath that little conclusion, that little discovery, I need to remind myself, draw that thing upside down. I'm looking for something upside down. Just making a list, identifying all the parts. Is there a parentheses? Nope, so h has to be 0. Is there anything added or subtracted after the square? So k has to be
0.
plus k. So what would, do you see a plus 1?
No.
I'll start making things up. Plus what? 0. There's nothing there. You don't see anything, don't put anything. Sorry, you don't see anything, it's a plus 0. Okay. So the vertex is at 0, 0. Think about the graph. The only thing that happened to the original graph, it got flipped upside down. It didn't shift left or right. It didn't shift up or down. It just got flipped upside down. The vertex is right here at 0, 0. And then it just flipped upside down. That's all. That's the only thing that happened. Make sense? Don't start seeing things that aren't there. They'll come to take you away.
Is there any negative 1 in the minus x squared or minus?
So what would a have to be? It would be f of x equals -1 times the x squared. Whenever you have a negative in front of anything, it's -1 times it. We just don't put the 1 part. When I have -5, that's the same as -1 times that 5. Okay. Yeah. That's something I don't ever think about making sure people get is like when we did this one and the slope of this x is just 1 because there's a 1 in front of that x. No, there isn't. Yeah, there is. 1 times x. If there wasn't a 1 in front of that x, we wouldn't have the x there at all. The coefficient is 1, and we don't write it though. 1 times x is just things. Yeah. And then when we do G, right here, identify the parts. What is the A here? It's still -1. What is the H? Do you have a parentheses?
No.
So H is still 0. Now it's K. K is +1. So our vertex, which is the ordered pair HK, is at 0, 1. 0, 1. 0 left and right. The x coordinate is 0 and the y coordinate is 1. And then it's, whoops, upside down. Hello. See, here's what I didn't do. Remember over here when I said I wrote down A is -1 and then I drew this to remind myself to draw it upside down. And over here I put the -1, but I didn't go, hey, don't forget to draw it upside down. And then I drew it wrong. And now, oh. But this second graph, -x² + 1, is this graph. And then what happened is we added 1 to all those old answers. Everything gets shifted up 1, and that's why it's right there. So what's K here? It's still -1, so it's still going to be upside down. What there's parentheses, and there is something in there with the x, so we do have H. What is H? -3. Opposite sign. Opposite sign. X minus H. X minus H. That's how we make the horizontal shift. Built-in negative, opposite sign of the H. Plus K. And then what's the K here? 0. So the vertex, the HK, is at -3, 0. 1, 2, here's -3. And then it's going to be opening down. Any questions here?
Right?
This, or that?
For the graphic, you see the vertex?
The vertex.
Yeah, the vertex, you have some A.
Oh, so that's just a sloppy. That's a sloppy page.
Oh.
H. It's always H. It was just sloppy. I said H when I wrote it, but you're right. My shoulder, I have, again, rotator cuff gone. So far, 2 surgeries, nothing left to repair. Because I tore it again. So there's nothing left to repair. And then this one, I don't even know what's going on with this one. So lifting my arms is like, okay, you're getting. Plus, I'm gonna. Yeah. So yeah, you can't read what I wrote. Yeah, you got it. You have it. And that's okay. Well, it is in my job description to confuse a little. Number 15. So 15 is graphing some square root. So negative square root x. G of x is equal to positive square root of x plus 1. And h of x is equal to the square root of x minus 2 and then plus. So up here at top, this is where I'll put the parent graph. You have simple square root x. Here we'll do negative square root x. Okay. So now the general equation for square roots will be y equals a square root x inside minus the h. And then after the square root happens, you would have, if there is one, a plus k, the vertical. So our parent graph, square root of x. The first point is at the origin at 0, 0. Square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. That's 1, 1. That's 4, 2. And that's 9, 3. That's what the parent graph looks like. Best thing you can do for yourself is make a list. So for f of this, what is a equal? Negative one. A is equal to a -1, so that means you're going to draw it reflected across the x-axis. It's going to flip. So instead of going up to the right, it's going to go down to the right. What about inside? What's the h equal? 0. There's nothing in there. What's the k equal afterwards?
0.
So that first point is at 0, 0. It's still at the origin. But instead of going up to the right, it's going to go down to the right. Just like that. Everything that's here would flip down. So this would be at 1, -1. This would be at 4, -2. And this would be at 9, -3. Now on comes G. So on G of X, look at A equal +1. So when you graph it, it's going to just do its normal up to the right. What is H equal? If there is one. -1. Built-in negative always. H is the opposite sign. H for opposite. So I see +1, that means it's going to be shifted to the left one. And then K. There's nothing after the radical, so K is it. So the first point is at -1, 0. Everything here is going to go 1 to the left. So it's going to go here. Instead of that 0, 0, it's going to be here at -1. Instead of that 1, 1, we're going to go 1 to the left. It's going to be at 0, 1. Instead of here at 4, 2, it's going to happen at 3, 2. Instead of at 9, 3, it's going to happen here at 8, 3. Now, let's say we go the wrong way. Let's say you went over here. I'm going to use this one. Let's say you went this way. And you plug in 1, and you think you're at 1, 0, and you're going that way, right? Here's how you would check. You're telling me that when you plug in 1, you're getting a y value of 0. G of 1, 1 plus 1, g of 1, does that equal the square root of 0? Everybody looking down so nobody can see that I wrote square 2. Does that equal the square root of 0? It's a yes or no? No. But when I plug in -1, see how it goes left? G of -1 is the square root of -1 plus 1. If -1 is equal to the square root of 0, G of -1 is 0. If you thought it was 1 to the right, then you're saying that this is going to be at 5, 2. Because it used to be at 4, 2, So you're saying it went to the right. So I plug in 5. I get 5 plus 1. 5 plus 1 would be 6. So when I plug in 5, do I get a 2? No. But if I plug in 3, 3 plus 1 is, and square root of 4 is 2. So it didn't go to the right 1 unit, it went left 1 unit. Instead of happening here at 4-2, it's now happening at 3-2. It went to the left 1.
So, because you can't have a zero square root, as long as there's an equation in there that.
No, you can have the square root of 0.
I mean, a negative square root.
They can't have the square root of that.
So if there is like a negative, as long as that equation has a positive and that equal, the output is positive, it's okay.
So you can just check a number, plug it in, and see if you actually get the Y value you're claiming it does. So here, A is a what? A is 2, 1. Okay. So up to the right, H is positive 2, K is positive 1. So that first point is now going to be at 2, 1. It's going to start at 2, 1. It's going to start here, and it's going to go in that direction. Most importantly, it's going to start at 2, 1. And it's going to go in that direction. And 6, 3. 6 minus 2 is? What's square root of 4? What's 2 plus 1?
Right, the A is just telling you basically what direction you're up in front of, it's just telling you which direction your equations.
Does it go up?
Where
Does it go down?
okay.
If A is positive, it opens in its normal direction. And if it's negative, it's going to flip across the x-axis. A can, and we're not going to do this to you, but A can also make it narrower or wider. Because you can narrow it or widen it. If I just had square root x, f of x was just 1 times the absolute, that's where an absolute value is. Then it's this. But if I had g of x and it was 2 times the absolute value of x. So it's still a positive 2, so it's still going up. But now you not only still have a positive, you're doubling all the old y values. You're multiplying by 2. So the y values that come out if you have a 2 in front are going to be twice as tall. So instead of having a 1, it's going to be a 2. Instead of a 2, it's going to be a 4. Instead of a 3, it's going to be a 6. So it's going to have a greater slope because that's exactly what it's controlling. It's controlling the slope of what's going on in here. And it makes it more narrow. And if I made it a 1/2, absolute value of x, then it would be wider because it would be going up half as fast. It doesn't move it left or right, it doesn't flip it, it doesn't move it up or down. It just makes it narrow or wide.
So that was -1/2, it would just be flipped over.
And it would be flipped upside down. And if I put a number inside times the x, then it stretches it or squishes it left and right. Put a number in front of the function, it stretches it and squishes it this way. And that's what life is. We just don't have nice, simple, everything doesn't move, doesn't change. It's one shape only. Okay? Special effects would be really boring if we couldn't do a whole bunch of stuff. Because that's what computer manipulation is all about. Is changing. CGI is math equations, everybody. Yeah, you film it, but it turns it into equations. Well, if you do the movies you watch based on math, it wasn't math. If you're watching soccer movies, maybe. Now, your test, these are multiple choice questions. Can you use it? Or you be even willing to try? Number 19. So number 19, 20, 19. And I posted this with you guys, right? I gave you a special printout or a special page of 19. So use the graph of F to sketch the graph, sketch each graph. You have 7 different things you're supposed to do. Okay. A is a separate problem from B, which is separate from C, and so on. So this is what I posted. It's all about ordered pairs. It's just about the ordered pair. That's something. And I think I'm going to stay about it. This is the picture of f of x. F. So what I did was I made a table. Here are all the ordered pairs that come out of function f of x. 0, -1, 1, 0, the 3, 1, and the 4, 2. We want to graph y equals f of x plus 2. Okay? So to graph this function, all you need are the ordered pairs for this function. Okay? Now, you could probably get away with, some of these without doing this ordered pair stuff. On your test, it's going to look a lot like the review sheet that I showed you earlier, where you have negative f of x minus 1 and then a -2. You have 3 things going on, not just one thing happening. That's why I put this little hint on the review sheet, and it will be there also on your test. Hint, ordered pairs. Use the given graph of f of x and its ordered pairs to plot, graph, and label the function. In ordered pairs. It's all about the ordered pair. So here's the table. I've got ordered pairs already. The graph I want to make is this old graph plus 2 more for the y values. Is there any change to the x coordinate? Is there anything? No, there's nothing being done to the x coordinate. Okay, the x coordinate here is the same x I'm going to use to make y. So these x's are all the same: 0, 1, 3, 4. Now, when will it be different? We can slide up there real quick. And down. Part C, part D. X minus 2, x plus 3. There's a change to the x before you actually take the value of the function. But for right now, that x is the same as the x's that I'm starting. And then the y coordinate. So here's how you get the y. The new y value is equal to f of 0. And then you add 2. Well, f of 0 is -1. And then we're going to add 2. So y is equal to -1 plus 2, which is 1. Plug it in. The y value that we want to make is equal to f of x plus 2, the old function plus 2 more. So I plug 0 into the old function, f of 0. What do we get? When 0 went into the old function, we got -1. It's right here. It's given to you. F of 0 is this -1, and then let's add 2. -1 plus 2 is 1. 0, 1. Right here. I'm getting it. And then we're going to plug 1 in. So the new y value is equal to f of 1 plus 2. F of 1 is 0. So y is equal to 0 plus 2. So I get 2. And then I'll put 3 and make my new graph. So y equals, plug 3 into the function, f of 3, and then we're going to add 2. When 3 went into the old graph, we got 1 plus 2 more. And 1 plus 2, we get 3. So when 3 goes into my new graph, I get 3. So right here. And then we'll plug in 4. So my new y value is equal to f of 4. And then we're going to add 2. The old y value when you plug in 4 was a 2. So 2 plus 2. And we get 4. So now when we plug in 4, we get 4. Take a straight edge. And just connecting these at 2 at a time. And what do we graph? We graph the old picture and everything has been shifted up 2 because it is the K value. A K value is the vertical shift up 2. Everything has been shifted up 2. This got shifted up 2 units. That one got shifted up 2. This one got shifted up 2, and that one got shifted up 2. Couldn't we have done that without making a order pair, plugging them in and seeing how it worked? Yeah. But showing it with a really simple example helps make us understand how to do it when the tougher ones come around. Because what we just did here is exactly how you do the tougher ones. Yeah.
So for like every time you point in X, like you're just gonna minus them. Because
I didn't mind saying.
I'm like confused with like the three, it's like the point is a three, and it's like y equals that. Like will be three inside and then plus two, and then like the next like column is like one plus two.
So
I just don't get it.
f of 3 is what? So when I put 3 into the old function, the y value for that was 1. So it was f of 3. I didn't take 1 away from 3 and just put 1, or subtract 2 and get 1. F of 3, I put 3 into the original function. And the y value when you plug in 3 is 1. Okay, yeah. That's because y is defined as f of x. So these y values, f of x, for these x's, and then I add 2 to these old y values.
Okay.
So when you look at this f of x plus 2, and we have this f of x plus 2, a f of x minus h, and then plus k. What's the a that's in front of this f of x? It's 1. Is there anything being done to x in the parentheses? Is there an h in there? It's a 0. And then after the function, k is a 2. So there's no reflection across the x-axis. There's no flip. There's no horizontal shift because h is 0. There's a vertical shift. It's been shifted up 2. Okay.
Something went wrong. Please try again.
No, I did it right. Wow. Sounds like me driving along with my kids home. Okay. The next one. And that's why, I separated this into 7 different pictures, or 7 different tables, because you could just start over again and not have to do it all again. So now, we want to graph y equals negative f of x. So in this case, what is a? Negative 1. So it's just going to reflect. All the graph is going to do is just reflect across the x-axis. If you have a positive y value, it's now going to be a negative y value. If you have a negative, it's now going to be a positive. Everything that was above is going to flip below. If it was below, it's going to flip above. Is there a horizontal shift? Is there anything being done to the x? No. Is there anything afterwards being done to the y values? A. No. H is a 0, K is a 0. So since there's nothing being done to the x's are going to be still 0, 1, 3, and a 4. What's being done is we're changing the sign of the old y values. So just so you see the substitution. So we're going to get y equals the opposite of f of 0. So this y value here is the opposite of the old f of 0. The old f of 0 is -1. So the new y value is the opposite of -1. It's going to be a positive 1. Okay. This y value, when we plug in 1, this y value here is going to be the opposite of f of 1. So this y value is going to be the opposite. F of 1 is 0. What's the opposite of 0?
How much left?
Number 9 to the right is what? To the right of 0 is positive. To the left, negative. Is 0 to the right of 0? No. Is 0 to the left of 0? So in order to be positive, you got to be to the right. 0 is not to the right. To be negative, you got to be to the left. 0 is not to the left of 0. So is 0 positive, negative? Neither. 0 is neither positive or negative.
Is 0 always true value?
So
Is 0 always true value?
0 is the absolute value. If I add 0, it doesn't change. So opposite of 0 is still 0. And once you start to see the pattern, you know that this y is just going to be the opposite sign here. So since this is positive 1, that's going to be a negative 1. And since that's a positive, that's going to be a negative 2. Because it's not that complicated of a transformation. Take the opposite of the old y values. Change that sign to a positive 1. 0 stays 0. Change that to a negative 1. Change that to a negative 2. So 0 positive 1. So that got flipped up. 1 0 doesn't change at all. 3 negative 1 is going to be here. So that's going to flip down. And 4 2 is now going to flip down here to 4 negative 2. Whatever was above is going to reflect below. If you're on the x-axis, then you're going to reflect above or below the on the x-axis, and you're going to reflect above or below. You're not moving, right? And then if you're below, you're going to reflect above. Above, flip over, below, flip over. Okay. And then on 19C, it's going to get interesting. But the game is played the same way every time. The rules aren't going to change. A, H, and K. Those are your best friends. For some of us, they were of course, that is not C, that is F. This So y is equal to a f of x minus h, and then a plus k. What is a right here? Positive one. Positive one. So no reflection. It's not the. There's something in there with x. What is h equal to? Positive 2. So everything's going to shift to the right 2. We're shifting right 2. And then k. Asking the function, k is a 0. So there's no vertical shift. So there's one piece of good news and there's one piece of you better think. The first thing, the good news. You see how there's no flip. A is positive 1. So the y values are going to stay the same side. And there's no vertical shift, so you're not going to add or subtract anything from the y values as well. So that means these y values are going to be the same y values. The y values are not going to change. That's good news. Remember, these are the only answers I have. It's not like I actually have an x squared or x plus 2 or anything to plug it into. I have nothing to actually plug some, a function to plug in, 2x minus 7. I just have to figure out where the graph is going to get moved, shifted, flipped, if it is. What's changing is the x's. What's going to change is the x's. It's a shift left or right.
Right.
To the right. We see x minus 2. Built-in negative. Built-in negative. So h is going to be a positive 2. Okay? It's going to shift to the right. So that means if we're going to shift to the right, I have to take this old x, 0, and I'm going to add 2 to it. That's the x that I would actually plug in for my graph. One more time. I only know what f of 0 equals. Okay? I only know what f of 0 equals. I can't plug negative 2. Yeah, or positive 2. I don't have a 2. So what I have to do is think about it. In order to get the answer for 0, I would have to plug negative 2 into my graph. Oh, 0 plus 2 is positive 2. Hello. I know, sorry. Ask. I'll be like, oh yeah, last Tuesday when you did that, 0 plus 2 is negative 2. I'm confused by it. I didn't fix it. I got 45 people that don't know what I did. Yeah, I can place the blame on somebody else. Welcome to America. Okay. I only know what f of 0 is. So in order to get 0, I need x minus 2 to actually make a 0 happen. That's all I can do. If I try to use 0, if I don't change this x, I keep the x the same, then when I plug it in here, 0, I'm going to be trying to take negative 2. I don't have an answer when negative 2 goes in. So in order for me to use these y values, I need 0. I need x minus 2 to actually equal 0. So that means I have to start this with positive 2, which is why it was shifted to the right 2 units. This is going to get shifted that way 2 units. So when I go into this, y is going to equal f of 0, and when 0 goes in, I get -1. 2 -1. Okay. So here's what you do. You know that h is +2. So you take this old x and you add 2 to it. This is going to be a 3. You're not actually plugging it in. You just want to know where that point's going to go. The y value is still going to be 0. This old x is 3. We're going to shift it to the right 2 units. So this x squared will be a 5 with this same 1. This old x is 4, and we're going to shift it to the right 2 units. So we can add 2 to it. So this new x will be a 6 with the 2. Watch when I plug it in. The new y value would be f of 6 minus 2. So that means my new y value would be f of 4. And f of 4 is 2. All I did was change the x coordinate by adding 2 because that's what h is. I added 2 to the old x. So now I got 2 -1. This is going to be 3 0. 5 1. And 6 2. The old graph has been shifted 2 to the right. Now, I just went over here and said, all right, we want to graph y equals f of x minus 2. So h is +2. Take this picture and just move everything 2 to the right and then redraw it. Probably not a big deal. I just said, let's just slide everything 2 to the right. But what happens when you have to flip it, shift it, left and right, and then shift it up and down? When you have 3 things going on. That's why the order pairs come. And you just tackle one piece at a time. B. With D, now what is H? What's going on in there?
Negative.
H is a -3. A is still a +1, so there's no flip. H is a -3, and K is still a 0. So we're going to shift left 3. Because that's a x plus 3, you're going to do the opposite direction, opposite side. So you're going to take this 0, this old x, and now you have to subtract 3, and the new x is -3. The y value is not going to change because nothing's being done to the function. This is a 1. We're going to go left 3, so we take away 3. It's -2. The y value is 0. This is 3. We take away 3, it's now a 0. Y value is still a 1. That's a 4. Take away 3 is a 1. Y value is still a 2. Everybody take 3 steps to the left. Oh, okay. This was at 0, -1. So we move it 3 to the left. So now it's at -3, -1. This was at 1, 0. So 3 to the left moves it to -2, 0. This is at 3, 1. So when I move it 1, 2, 3 to the left, it's at 0, 1. That's at 4, 2. So 3 to the left, 4 moves over to 1, and the Y value is still at 2. In what? Because H is a -3. Opposite side. And we have P. So here in part E, what is A? +2, but it's positive, so there's no reflection. It doesn't flip, but it's +2. We'll talk about that in a second. More important, what is H? 0. K is? So there's no horizontal vertical shift. Okay, back to some good news. H is not going to change, so it's still 0, 1, 3, 4. There's no vertical shift, but K is going to change because you're changing the value of the function. Remember, the value of the function is your y's. Y equals f of x. What's happening is it's 2 times the old y value. We're doubling the old y value. Plug in a number. Let's plug in 0. This y value right here is equal to 2 times f of 0. So that would be 2 times f of 0 is, I'm looking at it. So 2 times -1 is -2. So instead of being here at 0, -1, it's here at 0, -2. This one's going to be a little tougher to see because 2 times 0 is 0. Y is equal to 2 times f of 1. F of 1 is 0. So y is equal to 2 times 0, which is still 0. So when 1 goes in, it's still there at 0. Three. So y is equal to 2 times f of 3. What's the old f of 3? 1. So that's equal to 2 times 1, which is 2. So the old y value was 1, the new y value is up here at 2. And then we plug 4. This new y value is equal to 2 times f of 4. What's the old f of 4? So 2 times 2. That's 4. So when 4 goes in, it's now up here at 4. So what happens? It's not flipped, it's not a reflective. But what it is, it's a stretch. It got stretch. All the y values are double. So it's steeper. It's like changing the slope of a line. It's like 2 times x instead of 1 times x. And that's what happens when you change it. You know, we've just been dealing with 1 or negative 1. And that's all I'm going to ask you to do on your test is a 1 or a negative 1. Not going to make it double it or anything like that. But if it is a 1, a 2, or a 3, it's just 3 times higher. So it's going to stretch it this way or squish it if it's a fraction. You change the multiplier times the function. And we'll take care of the rest of 19. But you definitely have enough to get, all the way up through or start a lot of 1.5 and 1.5. 1.6 and 1.7, back to substitution and simplify. Home stretch, don't wait until the last minute to start the homework. You came in late, make sure you know I know you're here. You came in late, make sure you know I'm here.